Assalamualaikum and good morning, students. So this is the example 2 that I asked you to do yesterday. Okay, so let's discuss on this one. So basically this one is the example on insulated endpoints. So under heat equation we have zero endpoints, insulated endpoints, and also mixed endpoint. So the difference between all these is the boundary conditions. All right, the boundary conditions. So if given in the questions your boundary conditions involving UX and also UX, so meaning that this one is the case for insulated endpoints. Okay, so let's discuss on this one. So given the equation is del u over del t is equal to alpha squared del squared u over del x squared. Alright, so meaning that here, this is your ut, and this one is your uxx. So now, the first step is you need to let uxt is equal to xxtt. Alright, so we denote it as the star here. So from the equation, from the questions that you know that you need to find del u over del t. So meaning that we need to find del u over del t, and then we need to find del squared u over del x squared. So we get like this. Okay. Then what you need to do next is you need to substitute into the PDE equation, which is your given equation in your questions. Okay, what you have here, so you need to substitute inside here. So when we substitute inside the questions, so we're gonna get this one as our new equation. Alright, so next what you need to do is you need to separate the variables, so x with x and t with t. So you're gonna get it like this, and then you need to make it equal to lambda. So we make the equation equal to lambda. So from here, you're going to reduce from the PDE equation to ODE equation. So meaning that you're going to get two ODE equations. For the first equation is x double prime over x is equal to lambda. So we're going to make it equal to 0. So we will get this equation as our first equation of ODE. Then we're going to have the second equation where this one, so t prime over alpha squared t is equal to lambda. So make this equation equal to 0, and we're gonna get this equation as our second equation. So it means that here we have two equations of ODE. So the first one is for x, and the second one is the equation for t. Then we go to the second step. So in this second step, we need to form the boundary condition for the ODE. So now you need to see the boundary condition given in the questions. So when you see boundary condition given in the questions, it involving UX and also UX. So meaning that you need to find UX from here, because you already assume your function of u is equal to xt. So you need to find UX now. So here we find UX. So UX is equal to x prime x tt, meaning that we differentiate your function of u with respect to x. Then what you need to do next is you need to look at your boundary condition given in the questions. So this is the first boundary condition where ux 0t is equal to 0. So we're going to substitute inside here. So when we substitute, so we're going to get this one. Always remember that tt will not be equal to 0. So the boundary conditions that we will obtain for the ODE is this one, x prime 0 is equal to 0. Next, we have the second condition, which is uxlt is equal to 0. So same step, so we're going to use this one, and we're going to substitute inside here. So when we substitute, so same thing here, we're going to get this one, and t will not be equal to 0, so meaning that x prime L is equal to 0. So from here, we obtain your boundary conditions for the ODE. Okay, and we're going to use this boundary condition for the next step. Alright, then we will go to the third step. So in the step 3 here, we're going to consider all cases for lambda. You must check all cases. No matter in the first case, which is lambda is equal to 0, if you obtain that one is, if the equation is accepted, you still need to check for case 2 and case 3. Sometimes it is the combination of case 1 with case 3, or it is the combination of case 1 and case 2, or combination of all. So you must check for all. So now we want to check for case 1, which is lambda is equal to 0. So when lambda is equal to 0, so what you need to do is, from the equation of 1 just now, so you substitute lambda is equal to 0. So you obtain x double prime is equal to 0. So this is homogeneous equations. So what you need to do next is you need to find the root. So when we find the root, so we obtain your root is equal to 0. So we're going to form your general solution for x. So we obtain x is equal to a plus bx. After you obtain this general solution, so we need to find what is the value of a and b here. How to find? We're going to use the boundary condition that we already obtained from here. Okay, so we're going to use the first boundary condition. So the first boundary condition is x prime 0 is equal to 0. So we substitute x prime 0 is equal to 0. So meaning that the boundary condition is for x prime. So here we have the general solution is for x. So what you need to do is you need to differentiate this equation with respect to x to obtain x prime. So when we differentiate with respect to x, so we get the x prime is equal to b. Then after we obtain this one, then only we can use the boundary condition that we have just now. So x prime 0 is equal to 0. So you substitute inside here. So you get b is equal to 0. So when b is equal to 0, so from here, what left is x is equal to a. So that's why we have your general solution for x is equal to a. Then we have the second condition, which is x prime L is equal to 0. So you substitute inside this equation. So you still get x is equal to a. Okay. Alright. So meaning that here, so you obtain your general solution is equal to a. So means that it is not equal to 0. So this is not trivial. So we accept this one. So if we accept the general solution, so we need to proceed for the next step, which is to find your equation of t. So how to find the equation of t? So you need to use the equation of t here. T prime minus alpha squared lambda t is equal to 0. Okay, so here, so this is in case 1, so meaning that we need to use lambda is equal to 0, then substitute inside the equation of 2. So we obtain t prime is equal to 0. Then you need to find the roots. So m is equal to 0. So meaning that your general solution for t is equal to c. Okay, so how to get the general solution for t? So you have t prime is equal to 0. So of course you can find your t. So how to find? You need to integrate, class. Okay, integrate. So here you have your equation for x. you have the equation for C. So meaning that we can find the solution for U x t, where U x t is equal to x t t. So you just substitute inside. So x is equal to A, and then your t is equal to C. So you're gonna get A multiply with C. So that one constant multiply with constant. So of course it will equal to constant, where it is, let's say this one is constant D, or you want to put other constant also can. So your general solution for U is equal to D. So this is the solution for case 1. Alright. So meaning that we accept case 1. But since we already accept case 1, you still need to do for case 2 and case 3. Okay, remember that. So now we are going to do for case 2, which is lambda is greater than 0. So if lambda is greater than 0, so we're gonna let your lambda is equal to p squared. Then from the equation of 1, so you substitute lambda is equal to p squared inside. So you're going to get x double prime minus with p squared x is equal to 0. So here you need to find what is the root for this equation. So we let it equal to m, and we get your root is equal to p and also negative p. So this is two distinct root. So we're going to get your general solution for x is equal to this one. So same step, we need to find what is the value of A and B here. To find the value of A and B, you need to use the boundary condition that you formed just now, which is, alright, which is this one. X prime 0 is equal to 0 and x prime L is equal to 0. Okay. So we use here. So from the equation of x here, if you want to use the boundary condition is x is for x prime. So meaning that you need to differentiate this equation. So differentiate the equation with respect to x, and then you get this one. Okay, x prime x is equal to this one. So now we use the first boundary condition where x prime 0 is equal to 0. So you substitute inside here. So when you substitute inside here, you get 0. You get this one. 0 is equal to PA minus with B. Alright. So now we need to determine which term is equal to 0, which term is not equal to 0. So this is the first term, this is the second term. So your P cannot equal to 0. Why? Because in this case, for case 2, we know that your lambda is greater than 0. So meaning that your value of lambda is equal to P squared. So meaning that P must not equal to 0. Okay, because lambda is equal to P squared, which is greater than 0. So meaning that of course we know that your P will not be equal to 0. So if this one is not equal to 0, so A minus B will be equal to 0. Okay, so A minus B is equal to 0. So we can do A is equal to B. So we just substitute this one inside here. So we get this one. Alright. So then we test for x prime L is equal to 0. So we substitute inside this equation. So we obtain this one. Same goes here. Which term need to be equal to 0? Which term will not be equal to 0? We have P, we have A, and we have this one. So same with just now. Since this is in the second case, so lambda is greater than 0. So meaning that your P will not be equal to 0. And then if you see this one, exponent minus with exponent will not be equal to 0. Will never be equal to 0. Okay, since your P is not equal to 0. So if this one and this one is not equal to 0, so meaning that the term that will be equal to 0 is your A. So meaning that A is equal to 0. So after you obtain your A is equal to 0, so you substitute inside here. Okay, you substitute inside here. and then you get your equation for x is equal to 0. So if x is equal to 0, meaning that it is trivial solution, so we reject. So we reject case 2. So case 1 just now we accept. So case 2 we reject. So now we want to check for case 3. Okay, we want to check for case 3. So for case 3, we're gonna check for lambda less than 0. So lambda less than 0, we're gonna let lambda is equal to negative p squared. Okay, negative p squared. So from equation of 1, so we get x double prime plus p squared x is equal to 0. So we need to find the roots for this one. Okay, we need to find the roots for this one. So we get m is equal to plus minus pi. So when we form the general solution for x, so we will get this one. So same thing here, we're going to find what is the value for a and b. Okay, so by using the boundary condition in step 2, so the boundary condition is for x prime, so meaning that we need to differentiate this one, so we will get this one. So after we get your equation for x prime, so we use this boundary condition, okay, to find what is the value of a and b here. So here x prime 0 is equal to 0, so we will get this one. So either p or b is equal to 0. Okay, either p or b is equal to 0. So p will not be equal to 0 since lambda is equal to negative p squared, which is less than 0. So meaning that if p will not be equal to 0, so your b is equal to 0. So after we obtain b is equal to 0, so we substitute inside this one. Okay, so we have x is equal to a cos bx. So we test for next boundary condition for x prime L is equal to 0. So we get this one. Okay, so your same thing here, p will not be equal to 0. So we know that your p will not be equal to 0. Sine will be equal to 0 because sine PL is equal to 0. So PL is equal to n pi. If you have sine, so usually it will be equal to 0. Okay, so if p is not equal to 0, so sine is equal to 0, so meaning that a will be equal to 0. Okay, so only one term will equal to 0. So sine PL is equal to 0, so we have PL is equal to n pi, so p gonna be n pi over L, where n is for 1, 2, 3. So here, after you obtain this one, so you substitute inside this one. So you have this one. Okay, and we will write again, since p is in term of n pi, we have n here, so meaning that x and x is equal to a n cos n pi x over L, where n is from 1 to 3. Okay, we're gonna have summation after this. So since we get this one as your general solution for x, so meaning that this is non-trivial, so we're gonna accept this one. So if we accept this case 3, so meaning that we need to find, okay, your equation of t. So to find equation of t, so you need to use, alright, your equation 2 just now, which is for t. So substitute lambda is equal to negative p squared inside the equation of 2. So you're gonna get this one. So then same thing, find the roots for m. So you get this one. So to find t, so what you need to do is you need to integrate this one, and then you're gonna get your t is equal to this one. Okay, where just now your p here is equal to n pi. Okay, p is equal to n pi. So then you rewrite again your equation of t. So in terms of t, and t is equal to en of this one. Okay, so after you get your equation for x and then the equation for t, so you can get your solution for u. So u xt is equal to xt, and then you just this is the equation for x and this is the equation for t. So you just multiply. Okay, So this is the solution for case 3. So meaning that for these questions, you have two solutions, which is for case 1 and case 3. So in step 4, you're going to sum all cases. So to get, alright, to get your UXT, we are going to use the superposition principle. So this is for case 1 plus with case 2, which is equal to 0, and then plus with case 3. Okay, so your equation of solution for U is only this one. So after you get the solution for U, so we will use the initial condition given in the questions where U at 0 is equal to X. Okay, so U at 0 is equal to X, so meaning that this is your Fx. Okay, this is your Fx. So you have X is equal to D plus summation of this one. So you can see here, alright, summation of this one. This is going to map to Fourier series for cos, alright, for cos. So you recall back the Fourier series. For cos, you're going to have your Fx is equal to this one. A naught over 2 plus with the summation of this one. So this is the formula for your A, how to find your A naught and also AN. So for this question, your Fx is equal to X. Okay, so lambda L here is equal to L. So to find A naught, alright, to find A naught. So meaning that here, so this is your X, alright. So D is equal to A naught over 2, alright. So A naught over 2 is equal to D. So to find D, so D is equal to, so D is equal to, so to find A naught, alright, to find A naught, so it is equal to this one. So this is your Fx. So you need to integrate from 0 to L, alright, from 0 to L. So how you know your L here is equal to L here? This is come from here. So meaning that your L here is equal to L. Okay, so you integrate from 0 to L and then Fx dx. So you integrate X, so you're going to get this one, and then you get your A naught is equal to L. So A naught is equal to L, so meaning that L over 2 is equal to D. Okay, so meaning that your D is equal to L over 2. Then after you find your A naught, then you need to find AN. So to find AN, so this is the formula for AN, where 2 over L and then integrate from 0 to L. So this is your Fx, and then cos n pi x over L. So this one, you need to use tabular method. Alright, use tabular method and solve this one. So you're going to get your final answer like this. Okay, so not yet solved. So this one, your Fx, your equation of this one is equal to this one, right? Alright, so meaning that your final answer for U is equal to, okay, 1 over 2 plus this one. Okay, so you substitute back inside this one. So your general solution for U is this one. So D just now you obtain is equal to D just now is equal to this one. Okay, so the rest is this one. Alright, so this is the answer. Okay, this is the answer. So this is how to get the general solution for U. Okay, the general solution for U. Alright. Okay, so you check your answer whether the answer is the same with this one or not. Okay.